In this video, I'm going to be covering question 3, part A from the 2021 AP Calculus AB free response section, no calculator allowed portion. I cover each of these A, B, and C in their own separate videos just because they're kind of their own little topics, and you don't want to watch an hour-long video to get to where you need to be. So we'll break it up into bite-sized chunks here. So part A is telling us find the area of the region in the first quadrant bounded by the x-axis and the graph y equals c times x times the square root of 4 minus x squared. And then they're telling us, at least on this one, that c is equal to 6. So what we know right now, this graph up above, this is that graph. This is that cx square root of 4 minus x squared. And when we want to find the region bounded by that, that's going to be an antiderivative. That's going to be a definite integral. So we're going to do a definite integral. They told us that c is 6, so we could go ahead and plug in 6. And then we have the square root of 4 minus x squared dx. The first little hoop that we got to jump through on this is we got to figure out what our bounds are here. We're trying to find a definite integral, so we want to find our bounds. It's kind of pretty clear that one of the bounds would be happening back here at 0, but we can't necessarily assume that. The more important bound that we need to find is what's happening back here. And so those are all happening when y equals 0. So to find out where those bounds are happening, we would take that equation that we're working with, 6x times the square root of 4 minus x squared, and we want to set that equal to 0 to find out where these bounds are. Normally on one of these problems, you might have to factor it. You always want to get two things being multiplied together, and they kind of are nice here because they start us off that way. So what we can say is that we can now break this into two smaller bite-sized problems. So whenever 6x equals 0, we know we're going to have a 0, and then whenever 4 minus x squared equals 0, we know we'll have a 0 there. So we solve each of these little problems. The one on the left, pretty straightforward. Divide by 6, and we get x equals 0. That was the one we kind of assumed we had. That's going to be our lower bound here of 0. The one we got to do a little bit more work on is going to be this square root here. So we square both sides to cancel out that squared. Luckily, we've got a 0 on the other side, so that makes the math pretty easy. Now we're just going to solve for x, so the next thing I would do is add the x squared over to the other side to make that positive, and then we get x squared equals 4, and now I would come in and I would square root both sides of that. And when you apply the square root, technically this would be x equals plus or minus 2, the square root of 4. Well, we know the minus 2 would have been sitting over here, so that's not the piece that we want. So we would throw that one out. And what we can see now is that x equals 2 is going to be where that other bound is. So that's going to be our upper bound right there. So now we've got our integral set up and ready to go. And we look at that and you say to yourself, well, how am I going to attack that antiderivative? If you look down at your page and you see that it's not a bunch of stuff being added and subtracted, 3x squared plus 9x, things like that, and it's not one of those antiderivatives you should have memorized, one of your trig functions or an inverse trig function, then most of the time what you're running into is going to be a u substitution problem. And that's what we have here. We're going to need to go through our u substitution process. U substitution is a set of side work. It's the same set of side work every single time on this. And so what we'll do is we'll go through that process. Step 1, we always want to choose the u. When I go to choose my u, I've got sort of my own little priority list that I go through. The first thing I go looking for, if it's available to me, would be a natural log if it's there. If that's not there, then I go looking for what I would call the inside piece, as if I was doing a chain rule problem, a function plugged inside another function. And then if that's not there, the third thing that I go looking for is the bottom of a fraction. And then generally what I'm looking for, it's not always the case, but usually I'm looking for the piece that has the highest power of x. So if I go through this list looking at this equation, I don't have a natural log. That's not available to me. I do have an inside piece though. This 4 minus x squared was plugged into that square root function. So that's my inside piece, and it fits the other thing that I kind of keep in mind, which is I'm oftentimes looking for the highest power of x. So I grab my u. U is 4 minus x squared. From there, step 2 of the process on a u substitution is going to be to take the derivative of that. So we take the derivative, this is du dx, and you always want to use that differential notation, the du dx notation when you're doing this work. Then we take the derivative of the right side, the derivative of 4, the derivative of a constant goes away. The derivative of negative x squared following our power rule, bring the 2 down, we get negative 2x, subtract 1 from the power, gets us x to the first. The next part of our process here is we need to get this full integral up here talking nothing but the language of u. And that includes switching out this dx into a du. To do that, what I'm going to do is I'm going to solve this little derivative here to get dx by itself. So I multiply both sides by dx to get it out of the bottom. And then I'm going to go ahead and just divide by negative 2x. Divide by negative 2x. And I get du over negative 2x equals dx. So I'll be substituting that in. I'll be substituting this in. But when we've got a definite integral, we have one additional step. If there was no bounds on this, we'd be done right now. But because we have bounds, we also need to adjust the bounds. Remember, everything needs to be talking the language of u. And these bounds here, these are x values. So to adjust the bounds, what you do is you'll take your equation for u that you found up above. So we know u equals 4 minus x squared. And then we'll take each of our bounds from our integral and we're going to plug them in there. So I know that when x equals 0, I plug in 0 for x into this equation, and it's going to tell me what that equals in terms of u. So when x equals 0, u equals 4. And then I do the same thing for that upper bound up there. So when x equals 2, sorry, I was already doing the math in my head. When x equals 2, u equals 4 minus 2 squared. 2 squared is 4, so we get 4 minus 4. That equals 0. So these are now going to be our new bounds. After all that work, we are now ready to go back and actually do the substitution part of our u substitution problem. So we're going to come back up here and we're going to substitute in for u, we're going to substitute in for our dx, and we're going to substitute in for our bounds. So working your way left to right, it's either one of those three things that you're subbing for, or it sticks around for the time being. So up top here, that lower bound now was 0. It's now going to become 4. That upper bound was 2. It's now going to become 0. Nothing happened to that 6x yet, so we're just going to leave that there. Now this is all going to be the square root, and all of that stuff is now u. And then dx is now going to be du over negative 2x. At this point in the process, if you've got any x's left in the problem, they should ideally cancel out with x's you just plugged in. And so sure enough, that x on top is going to cancel with this x on bottom. The other thing we can do here is we've got a 6, and this is over a negative 2. So we can simplify that down to being a negative 3. So if we kind of start bringing this simplification together, 6 divided by 2 gets us negative 3. I want to do a rewrite on that. Remember that whenever you see a root in a problem, that's a rewrite that you want to be on the lookout for. This is our power over root rewrite. When you have x to some power inside a root, you want to rewrite that as x to the power divided by the root. So if you had something like the cube root of x to the 5th, you'd want to rewrite that as x to the power of 5 over the root of 3. So in this scenario, we have an unwritten 1 for our power, and we've got an unwritten 2 for our root. So this would be u to the 1/2, and then du. And you essentially at this point should be talking nothing but the language of u. And this is what I call your reward for all your hard work. This is a brand new math problem. And so ideally what you've done is taken this from something you do know how to take the antiderivative of, or you don't know how to take the antiderivative of, and ideally turned it into something that you do. We have a little bit more simplification to handle before we get going. The first thing we would want to do is pull this negative 3 to the outside. Oftentimes when you've got a constant being multiplied, it'll make your life easier if you pull it to the front. The other thing we've got to look out for on this one is that our bounds are messed up. We always want the lower bound to be the smaller number and the larger bound to be the upper number. So we want to move that lower bound, flip the bounds here. So to flip the bounds, when I want to switch this from 0 to 4, you do what I call pulling a negative. So essentially what you do is you get another negative out front here because you flipped the bounds. You pull that negative and that flips the bounds, and that's going to leave us with u to the 1/2 du. Now we're ready to go ahead and finally take this actual antiderivative here. And so on this problem, when we go to look at this right now, this is going to be just our power rule. So the power rule for integrals that I use goes add 1 to the power, and then step 2 of that process is divide by the new power. So as we come through here, we're going to have this positive 3 that's still sitting up front. Then we'll add 1 to the power. That's going to get us u to the 3/2 divide by the new power. And then because we have bounds, we're going to evaluate this from u equals 0 to u equals 4. And now I just do what I call top minus bottom. I'm going to take the top value, I'm going to plug it in, and then I'm going to subtract off the bottom value plugged in. The whole thing is going to be multiplied by 3. So that 3 is multiplied by all this math. So make sure that you do the math for the top minus bottom separately and multiply it by a 3 at the end. So the other little details, all these little details as you come through here, when I'm going to make my life easier, I want to flip that back to look like it normally would. So that 3 over 2, I'm going to flip that to be a 2/3. I'm going to plug in 4 for u, so I get 4 to the 3/2. Then I'm going to subtract the bottom plugged in. Again, I've got 2/3, and this time I've got 0 to the 3/2. Luckily, you don't have a calculator, right? So you've got to be able to decipher what this means right here. Remember that that is your root, and that is your power on top. And so when I look at this right now, I've got 3, and then this would be 2/3, and I would think about it as the square root of 4 to the 3rd, and then luckily for us, 0 to anything is just 0, so we would have just a minus 0 on this end. So finishing this up, we would have that 3 still sitting out front. We've got our 2/3. The square root of 4 is 2, and then 2 to the 3rd is 8, so then this becomes 8. And now as we finish this up, I've got this 3 and that 3 would cancel. I get 2 times 8 is 16. And don't forget your units on this, right? So if they talk to you about inches, if you see units in the problem, remember you need units out as the answer. It's an area, right? So you know that what you're looking at is square units. So this would be inches squared. And that would end up being the final answer on this piece. So this question would be worth 3 points total. The first would have come from just right up at the top here. You'd have earned 1 point from setting up that integral. The second piece would have come from getting out at least the 16, and then the third point comes from making sure you got your units attached to it. So 3 points for this whole problem. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.